Hello everyone, we'll start with our next unit, which is your data link layer. So telling about this data link layer, the very second layer is your data link layer. So where you get the data from, from which layer you get the data from is your network layer. So from the network layer, your data link layer transfers the data which are received from your network layer into a packet of data units called frames. So now we are going to discuss in detail about the data link layer. So this data link layer, the main function of that is to communicate the data from a node to node, which means a device to device. So already we have discussed that a framing concept is involved. That is, the frame contains the bits. So your message length is stuffed in terms of bits, and your message length can be divided into equal number of frames. So if you see that I can't send my message as a whole to one network. So what I do is that I segment the entire message as a frames. So that frames sends from the receiver and it finally reaches the destination, and on keeping some of the sequence number, it gets arranged in your receiver end. So next one is your addressing. So addressing, you all know that it is your physical address, embedding your physical address in your frames, in your header section. So next one will be your error control. So this is one of the main concept in your data link layer, where your trailer portions in the frame contain some error detection and correction mechanism. So next, coming to the flow control. So flow control we have already discussed. So the receiver must contain, he must have some enough memory to receive the data whatever the sender sends. So if at all the messages overflows in the receiver end, the data might be lost. So that is the flow control. We have to send the data in such a way that the receiver doesn't overflow in his buffer size and the data might not get lost. So next one is your medium access control. So this one takes care of the which computer in your data link node takes care of that transmission medium, or the which computer is taking care of sending and receiving the data. So all these comes under your data link layer functions. So first starting, so we will discuss about the error correction and error detection. So we will start with the basic terminologies of that, and then we will jump into the mechanisms of how the errors are detected and corrected. So first, so these are all the introductions I have told you now. So first one is our error detection and error correction. So in that, first you must know what is an error. So how an error occurs? So if I send a data and it has some interference in the transmission medium, or it has some disturbances in the transmission medium. So because of that disturbances, my data gets corrupted, which means that my bits get corrupted. So on the receiver end, my data will not be original, it will be in the form of corrupted data. So that one you call it as an error. So let us see what are all the types of error in this. So first one, you have a single bit error. So this is my sender data, which is in terms of bits. So now I am sending this to my receiver. On the transmission, you can see that this data is changed, which means that this one got corrupted and it has sent to the sender. So this is your single bit error. So whenever there is a change in a single bit in your frame, you call it as a single bit error. These errors are rare in case because we might not get any single bit error only in the transmission times. So next one, you have burst errors, which means that the minimum of 2 errors and the maximum of how many ever it can be. So if you see this, so this is my sender data and this is what the receiver has received. So there is some flip in the data. So these are all the errors that have occurred in the receiver side. So these types are known as your burst errors. So these burst errors, the changing, it need not be consecutive. I can't assure that my errors might occur in a consequence. I mean, the continuously my data bits will not be corrected. So my data bit will be corrected in one, say some third position, and next it might be on the 7th position, or it might be even in my 15th position based on the length of the data bit frame you sent. So this is what is your burst error. So next, how can we detect or how can we correct this type of error? So we have a concept called redundancy, which means that on sending my original data bits, I will add some extra bits in my original data, that is the sender side data, and I will send to my receiver. So the receiver, with the help of that redundancy bits, he checks whether the data is corrupted or not. So the main concept here is your redundancy. So redundancy, it is of the extra bits to detect your and as well as to correct your errors. So next, coming to what is the difference between the error detection and error correction. So detection is that we have to find that whether our data received by the receiver side has a valid message or not. So I will just tell them that yes, this is my original data, it is a valid data, and this is not my original data, which is an invalid data. So that is all about your error detection portion. So I need not worried about where my error has occurred and in which place, all other such things. So my intention is to only tell the received data and the receiver side is a valid or not. That's it. So coming to the error correction, so if we want to correct the errors, before that we must need error detection. So error detection and error correction goes hand in hand. So the error correction is, you will tell the how many number of bits is corrupted and where, in which position the flip-flop, means the data has changed, and what is the original size of your message bit. So these are all the parameters you will be considering for your error correction. So these are the difference between the detection and your correction. So next, moving on, you have some two methods how to correct the errors. So detection, we can tell it is a valid or invalid. So correction, how can it be corrected? So if at all the error is small, say for example I have one error or two error, so I can make, the receiver can make a random guessing by keeping the redundant bit in mind, and he can get the original bits. Or if the error is more, if there is a lot of error in the receiver side, so the first method or the main method is to tell the sender that you please retransmit your data because there is an n number of errors in whatever data you have sent me. So the second one will be the retransmission. So these are all the basics about your error detection and error correction. So next one, we will move on to the methods where how can you detect the errors. So first method in that will be the block coding, which is a basic concept and it is not advanced, which tells you about the error detection. So coming to block coding, so I told you priorly the redundant bits. So how this redundant can be, in what method it is implemented, in the sense it is used in your block coding. So let us see what are all the steps involved in your block coding. So first you have the original message bit. So later it is divided into some block of k bits, which is termed as your data words. So first you're dividing the original message into so many blocks, whatever you wish, and you call that one as your actual data word, which means that your original message. Next, for each block of your data word, you add that redundant bit, which is your R bit. So on final, I will get the length of my message to be sent. This is my message. So finally my length of this message will be the length of one block with whatever redundant bit I have added. So your data word can be in terms of 2 power k. So next, your code word can also be, so this one we call it as a code word, which you are sending it to the receiver side. So if I take an example that if suppose my k bit is 4 bits and my n bit is 5, the length of my n is 5. So how can I take this as, so which is 2 power 4 and 2 power 5. So 2 power 4 is 16 and 2 power 5 is 32. So this is the length of my actual data word and this is the length of my code word. So if you see the difference, so out of 32 bits, only 16 is the message size, whereas the other 8 bits are not used or it is used for some other purpose. Yes, so this is the concept of your data word and your code word. So how do we choose this R bit? So that we will discuss later. So let us see under block coding how the errors are detected. That is your error detection. So on the error detection, the receiver has to tell whether it is a valid code word. Yes. So next, if at all it is not a valid code word, he must just discard the data whatever he has received. So let us see the design of how this error detection has been designed in your block code concept. So this is your data word that you are saying, that is, which is your k bit. So next you are feeding into a portion called as a generator. So this generator is responsible for generating your redundant bits, R bits. It uses some mechanism and it generates some R bits. So on generating, so these both will be combined and it gives me a code word, which is nothing but your n bit, what we have seen here. This will be in my sender side. So what happens at the receiver side? So what happens? So my code word will reach the receiver. Next, I have a function called checker function. So this tells that whether the received code word is correct or not, which means that it might discard if the code word is not original, and if it is valid, it will extract the original data word from this code word. So I can simply say that it is the encoding concept at your sender side and this one will be the decoding concept at your receiver side. So this is a normal design of how your error detection happens. So let us look into an example. So I will have some data word and code word. So these are all the code words. Yes, so on generating the redundant bit, it will be converted into the code word. So you can see that these are all the redundant bit that it is added in your sender side. Okay, so I shall explain you the cases. So if at all I am sending a code word 011. So I am sending this particular code word to my receiver. So my first case is that the receiver tells that it is a valid code word. So no error has occurred and he tells us the valid, and he extracts the data word from this code word. The data word here is that 01. So he extracts this message from the code word. This is one such case. So next one, on sending this code word, on the receiver side, he receives the data like this. So what happens? So this single bit has got corrupted, which means that your leftmost bit got corrupted. So this is not a valid code word. You can see from the table, yes, so 111 is not a valid code word in the code words given. So what the receiver does, so he simply discards this message. So next, coming to the third case, this is my original message. So on the receiver side, he has received some 3 zeros. So which means that the two most left bits got affected. So upon receiving this, when you check with the code word in the table, this is a valid code word mentioned in the table. So the receiver, he undetects the error. The error left undetected. So what he does, he extracts the code word. On the extraction, the data he receives will be 00, which is not the corresponding data word for 000 will be 00. So he extracted a invalid data word. So these are all the cases where your errors can be detected. So this type of errors, it can identify up to a 1 or 2 bit error. So next, moving on to the error correction. So even before errors could be corrected, we need the error detection. So next, let us look into the example. So my data word and my code word, I will give some data word. So I have added some 3 R bits in my code word. So suppose I am transferring this particular code word to my receiver. So first case is my valid case, that is of no problem. Next one, this message got corrupted and it has changed to some 01001, which means that this bit got corrupted. So in this case, what I do is that I check my corrupted bit with each of the code word in the table. So I will make a bit by bit comparison. So first, coming to the comparison of the first one, 0000. So this tells me that how many bits has changed, like 2 bits has changed. This gives me a 2-bit difference. So next, on comparing with this one, my second, it gives me 1-bit difference. So next, on comparing the corrupted bit with my actual code word, so this gives me 1, 2, 3 bit. So next, on comparing to this one, it will give me 1, 2, 3 and 4 bit. So the receiver will identify that there is actually 1 bit corrupted and that is close to this particular bit. So upon the comparison, he will tell the actual bit to be received is this one. So by this way, the receiver will identify as well as he will correct the errors. So this is how your error correction happens in your block code. So next concept is Hamming distance. Hamming distance is one of the method to control the errors. How the errors can be controlled. So what does this Hamming code tells us that when you have 2 data words and the difference in that data word will correct the bits. So this Hamming code tells that, so whenever you have 2 data bits and the difference in the number of bits that got corrupted will be the Hamming distance. So let us look into an example which makes you a little more clear. So this is my data word and this is my code word. So now we are looking into the difference in this code word. That is, the Hamming distance is represented as the distance of your 2 code words 0, 0, 0, 0, 1, 1. So how will you find the distance? So we make use of a XOR operation. So the truth table of your XOR will be 0, 0 is 0, 0, 1 will be 1, 1, 0 is 1 and 1, 1 is 0. So this is the truth table of your XOR. So upon this we will tell how much difference does these 2 code word has. So what is the difference between this now? So I have some 2-bit difference. So next, difference of 0, 0, 0, 1, 0, 1. So this, how many difference do I have? 2. So simply I can identify it like this, or you might perform an XOR operation. That is, this has changed and this is changed. So that's why it is 2. So next, D of 0, 0, 0, comma 1, 1, 0. So here you can see it is of 2. So next, D of 0, 1, 1, comma 1, 0, 1. This is also 2. This is just a combination. So next, D of 0, 1, 1, comma 1, 1, 0. Here also the difference is 2. So D of 1, 0, 1, comma 1, 1, 0. Here also the difference is 2. So the maximum errors that might occur in the receiver side will be of 2, which will be the minimum distance that will occur in your receiver side. So upon exceeding this error, so it is impossible for the receiver to detect it. So these are all the performance in your sender side. The sender will tell at the max there might occur 2 errors for the receiver. So if at all the errors goes upward and it reaches some 5 errors, so he can find 2 errors and the other 3 errors left undetected. So now we had the same number of errors that will be happening in your receiver side. What if my Hamming distance is like in this case? So when you look into this example and you have to find the Hamming distance of this one. So what you do? D of 0, 0, 0, 0, 0, comma 0, 1, 0, 1, 1. Yes, so what will be the minimum difference in this case? It will be some 3. So same, D of 0, 0, 0, 0, 0, comma 1, 0, 1, 0, 1. So this will be 3. So next, 0 and 1, 0, sorry, 1, 1, 1, 1, 1, 0, which will be a difference of 4, which means that 4 bit has changed. The difference between these two words will be 4. So next, 0, 1, 0, 1, 1, comma 1, 0, 1, 0, 1. So here the difference will be 1, 2, 3, 4. So next, D of 0, 1, 0, 1, 1, comma 1, 1, 1, 1, 0. Here also the difference will be 3. And finally coming to the last combination, 1, 1, 1, 1, 0. So in this case it is 3. So the combination of these code words are like some 3 or 4. 3, 4 I have. So in this you have to take the minimum distance, which is a concept called as a minimum Hamming distance that the receiver will identify. So I will suggest him that there is a possible of 3 errors occurring in whatever data you receive. So for my errors, or if my error is 3, the maximum code word, that is the maximum data word, how should it be? It should be the times of error plus 1. So if 3 errors are happening, my message length should be higher. So it should be like 1. So for 3 errors that might happening in my message, my original data must be the length of 4. So this is the concept of your Hamming code. So these are all the methods in your block coding, which is a basic concept of your error detection and error correction. So in next session, we will look into the type of methods or mechanisms which involves the error corrections. Thank you.